Today, I'm excited to present my project based on gas detection using MQ6 sensor interface with the AT89C52 microcontroller. The main objective of this project is to detect the presence of LPG, butane, and other combustible gases in the environment, ensuring early warning for potential gas leaks, which can prevent accidents and save lives. The MQ6 sensor is highly sensitive to flammable gases and provides an analog output depending on the gas concentration. This output is read by AT89C52, an 8-bit microcontroller from 8051 family, which processes the signal and activates an alarm or alert mechanism if the gas concentration exceeds a safe threshold. This project not only demonstrates real-time gas monitoring but also emphasizes the importance of embedded systems in safety and automation application. It's simple yet effective system that can be used in homes, industries and gas storage areas.
Components which we are used in this proposed system are AT89C52 microcontroller. The AT89C52 microcontroller is the main processing unit of this project. It belongs to the 8051 family and comes with 8 KB of flash memory to store the program and 256 bytes of RAM and 32 IO pins in which consists of 4 ports in our system. In our setup, it plays the central role by continuously monitoring the input signal from the gas sensor. When the sensor detects a gas leak, the microcontroller processes the information, immediately takes the action like displaying the message on the LCD. It's ideal uh, it's ideal for small embedded systems like this, thanks to its simplicity and wide community support. The second most important component in our project is MQ6 gas sensor. The MQ6 gas sensor is a highly sensitive sensor used to detect flammable gases such as LPG, butane, and methane. It works by measuring the change in conductivity of sensing materials when exposed to these gases. For this project, we use its digital output, which sends low signal to the microcontroller when the gas concentration crosses a certain threshold. This makes interfacing simple and eliminates the need for a complex ADC circuits. This the sensor is fast, reliable, and cost effective for gas detection systems. I2C LCD display. We are using 16 into 2 character LCD display with an I2C module for displaying messages. The I2C interface allows communication using just two wires, SDA and SCL, which reduces the number of IO pins needed on the microcontroller. This display shows the status like gas detected or environment safe in real time, helping the users understanding the current condition at a glance. Its backlight and a clear text makes it suitable for both indoor and outdoor environment. 5-volt DC power supply. The whole circuit operates on regulated 5-volt DC supply. This is important because both of the sensors and microcontrollers requires a stable power source for accurate operation. A 5-volt battery pack or a voltage regulator circuit like a 7805 to maintain consistent voltage levels. The software tools which we are used are Kale Microvision IDE. Kale Microvision IDE is the software we use to write and compile our program for AT89C52 microcontroller. It supports C language and provides a simple environment where we can write code, debug, and simulate how our microcontroller will behave. After writing the program logic for detecting gas and controlling outputs, Kale compiles the code and generates a hex file. This hex file is what we load into our microcontroller. Actually, functioning Kale also includes simulation features for code testing before hardware implementation, making it an essential and tool in embedded system development. Proteus design suite. Proteus is a circuit simulation and PCB design software. In this process, it is used to simulate the complete working of our gas detection system without any physical components. We can design the circuit by placing components like AT89C52 MQ6 sensor module, LCD display, and power supply. Then we import the hex file from the Kale into the AT89C52 microcontroller in Proteus. When we run simulation, we can see how the system responds to the gas detection in real time. This helps us verify the logic and detect errors, fine tune our circuit before building the actual hardware.
Okay, to first program in Kale, open Kale Mu Vision 5 software in your desktop. Then close the already existing projects in the Kale app. Then create a new project using create new Mu Vision project in Kale. Then select the microcontroller AT89C52 from the device list. Then go to Files and click New. Write your code and save it with .c extension. Then, in the project window, right click on the source group 1 and add existing files. Then, select the C file of our program. Then, initialize the LCD. Use the digital input pin, example P1, to read from the MQ6. Display the status on LCD based on the pin value. Click the build button for to build the program and make sure there are no errors. If there are any errors, rectify it. Then go to the project, open the options for target and click the output and check create hex file. After giving hex file, give OK and rebuild the project. It will create the hex file to upload in the 8089C52 microcontroller in Proteus file. Then close the Kale program and open Proteus simulation and open a new project or a new schematic. Press P to pick components. 89C52 microcontroller, 16x2 LCD display, resistors 10K for pull-up, push buttons to simulate MQ6 digital output, power source, battery 5-volt battery power source, ground terminal, connect the MQ6 sensor output pin with pin 3.2 in 8089C52. Then connect 5-volt battery power supply for a VCC terminal in MQ6 sensor. Connect a ground terminal in the ground pin and connect a toggle pin which is used to give the input for the sensor in the test pin. Then connect the LCD screen display with 8089 with pins D1 to D7 with pin numbers P1.0 to 1.7. Then connect VSS pin to ground, VDD pin to a 5-volt power supply, and VE pin with a potentiometer to adjust the screen density of the LCD monitor. And connect RS pin with P2.1, RW pin with ground and enable pin with P2.2. Now run the circuit using the run button at the left hand corner of the screen. When running, give the toggle pin 0. It will give the input as a low for the MQ6 sensor. Then the LCD will display the system normal as output, which means there is no detected gas or any abnormals in the environment. If the toggle pin is changed to 1, then the LCD will display the gases detected, which means the MQ6 value is high, that is, the gases detected in the environment. The project can be used in various application factors like home safety systems, which detects the LPG or gas leaks in kitchens and automatically triggers an alert on the screen. Can be integrated with a fan or exhaust system to reduce gas concentration. Industrial gas leak monitoring monitors hazardous gas levels in chemical plants, refineries, and storage areas. Helps in preventing fire or explosion risks in industrial environments. Smart kitchen appliances can be embedded into smart stoves or gas regulators to alert users of leak or incomplete combustion. School or college projects ideal for education demonstration on embedded systems, sensor interfacing, and real time monitoring. Gas cylinder storage areas alert security or management staff about possible gas leaks from stored gas cylinders. Vehicle gas detection system useful in vehicle running on LPG or CNG to detect any internal leakage.